Good morning. My name is Mohamed Fazil. I'm going to explain about the novel fabrication methods of ultra thin gauge metal sheets. And this is for my engineering research methods 955. And the first part is we all know that metals play a very important role in shaping the modern world. As the technology that develops, there is a demand for the manufacturing of thin metal sheets in all the industries, starting from defense to artificial intelligence. Even though there are a lot of traditional methods that are involving in manufacturing the metal sheets, there is an absolute need now for the manufacturing of additive measures and novel techniques in manufacturing the thin metal sheets due to its huge demand. The development of artificial intelligence as well as the automation industry has speeded up the process as we need more precise and short materials for the manufacturing of all the elements related to these industries. So there is a huge demand for the novel fabrication technique with more precision and efficiency. And the very need for the manufacturing techniques of the thin metal sheets is, as I explained before, the traditional methods lacks the ability to adapt the automation. Even though they have very good efficiency, they can't cope up with modern techniques, mostly about the automation. And considering about the precision and accuracy of the materials, it is not satisfactory for the old traditional methods to compete with the new methods. And the main thing that I am focusing on is the precision and accuracy of the materials that are created by using the traditional methods. And this is the process. These are the novel techniques that are related to our topic. And these are the techniques that are now available for the creation of ultra thin gauge metal sheets. And I'm focusing mainly on the ultra thin metal sheets forming and also the laser shock microforming, which uses a laser to create the microforming process, which I'm going to explain after this. And my research question is, I want to generate ideas for the novel fabrication process of ultra thin metal sheets which focuses on better precision and accuracy, and also it must be futuristic. And my process is the research design that I'm going to explain is about the laser shock microforming with water jet to increase the efficiency of the product as well as to remove the other debris that are available over the product. And the first thing is we have to select a thin metal sheet, and it has to be exposed towards a long pulse NS laser, like to get a laser shock. Once the product get the laser shock, the vaporization effect will start on the metal surface, which creates a deformation of the product. And then if needed, by looking at the surface of the product, if it needs some finishing, we have to expose the product to a water jet to remove the excessive debris over the product. And this is the design process. The first step is I have to explain that this is a combination of literally two design ideas to maximize the efficiency of the material. And the first step is, as I explained before, we have to select the desired metal sheet. And once the long pulse NS laser is made to fall over the material, first we have to change the circular beam into square beam lasers by changing it from using the beam shape converter. Then due to the laser beam, the vaporization effect is beginning to happen over the metal, which will in turn create a deflection over the metal sheet so that we can form it to our desired shape. After every process is completed, we have to look at the product. We have to keep up the finishing. If there is any debris left over the product, we have to put the product to the water jet, which will in turn clean all the debris over the products. And the main advantage of using the lasers in the forming process is that the output metal sheet quality is very good and it doesn't require finishing process in most of the times. This must be a futuristic product and it can be adaptable for automation as well. If set up efficiently, we can create a large amount of output materials within a very shortened span of time. For me, it is a versatile process that can be used for a longer run, and it can be a very futuristic one. There is no need for several human resources, and also these processes can be installed to achieve a greater output. These are the references I used to achieve this project, and thank you so much.